Shasta High School. I'm Adam Seafall.
And I'm Rena Morrison.
This will be our presentation on ancient number systems. Let's get started.
One important thing about number systems is that they change when we change. And the more mathematical means we have, the more advanced we need our number systems to be. So imagine that you're herding a flock of sheep, and you need to keep track of the sheep that you let out in the morning and the sheep that you gather back at night. If your flock is small, you can easily remember each sheep by name.
So you can name like Mo and Larry and Curly and Bill and George and Brock. But if you have a much larger flock,
it becomes difficult to keep track of the sheep you had in the morning and the sheep you had at the end of the day. What you can do is use objects such as twigs and stones to represent the sheep and move them from one area to another as the sheep leave. This is a primitive number system.
so as that develops, we see that the Mayans used something just like that.
The Mayans started with the physical objects to represent numbers such as the twigs and stones.
So, like their currency, which was the cocoa bean, could obviously, or stone, be represented by a dog, would gradually be replaced by a twig or a 5, and that just kept increasing. Also, their base 20 was from the hands and feet that it's been before, but they needed this due to their large empire. They had to be able to talk across great distances and convey numbers, which is why they gradually developed this written system.
And also, they had the number 0, which was represented by an empty bowl or a shell or an impression in the ground, but we don't really know why they represented that as 0.
Yeah, we don't. Many theories exist. My personal theory is they had sheep, and then suddenly they had no sheep, and so they tried to explain why they suddenly had no sheep. So what took the sheep but that object, which is their 0? The more sophisticated system would be the Egyptians.
The Egyptian system was also representative of physical objects, but it was more symbolic than the Mayans. Each unit of 10 had its own specific symbol, and the larger the number, the more symbols used. For example, the number 50 would be represented by 5 of the 10th symbol.
But this system was still very physical. They were simply drawing objects they were familiar with, and so it wasn't quite a modern system, so-called, but they still had a more numerical sense than a practical sense, allowing them to do some problems, many more calculations like engineering. And so, even though a million, wow, is still just an amazement, it's still very connected to what it was originally, but now they have a system which can do true calculations.
The Greek system is much more modern because it started using abstract symbols with specific notation to represent different numbers, and this made writing numbers much more compact.
Yeah, in this one example, they had several number systems, which would make sense because of the individual city-states. This is, I believe, Apollonesia's writing, which is more their symbols totally unique to writing in itself, also shared some of its language. And you can see there's 27 symbols which you had to learn, 28 or even 29 as you got into higher numbers by notation of the larger n. So it wasn't their place value, so-called. They wrote it in that format from large to small, so it was really redundant because they had each individual symbol, which they didn't truly need. You could write it in a different order, just be like misspelling of words, you could still get your point across. And so in that sense, it's not truly a modern positional system. So just looking back, all these systems are determined by how efficient they were. These people wanted to do what they needed to do, depending on how developed and how complex they were, but they wanted to, as well, save space. We see this horizontal format gradually get replaced, or vertical format gradually get replaced with horizontal, and also gradually gets smaller. The Mayans, of course, as a base 20, is not very compatible with these base 10s, but they were still able to do, say, like addition and subtraction, as we'll show you in a moment. The Egyptians did it in a much similar way by simply adding all of the units or subtracting the units, then simply moving over like how we carry digits. And so, on the side here, they would simply add across, get all of the units of one kind. So you would have, say, 5 of the stakes, 7 of the dots, and then they would have to go in and manually up the value, much like our current system would kind of carry in our addition. And their 0 again was a placeholder. It was empty, and as the system grew larger, it kind of broke down into a kind of almost base 20, which was also related to their calendar being 260 ritual days, 365 civil days, which allowed for this very odd cycle of events. And they had to do all these calculations they did do manually. As you see here, you have to take, all right, 1, 2, 3, 4, 5, 6 dots, would then be transposed to a line. 1, 2, 3, 4 lines would be 1 dot of a higher value, and they continue this until they get to the actual answer. And obviously my mind math is not as good because I just made a mistake. But as you can see, it's very laborious in that you have to keep transferring over all of these symbols into different values. As I said before, like carrying, you put a value here. What they would write is an 11 unit, which is not a true unit, and then have to carry it out. It's not as efficient as our placeholding today.
Our modern system that we use today has all aspects of these number systems. Symbols, positional value, the number 0, and
I mean, you're familiar with it. It's base 10, and it allows us to write large numbers compactly and get our point across with minimal effort, which allows our number system to be such an integral part to our civilization. It's not just scribes or accountants. It's everyone calculating how much gas they need to buy, how much their groceries cost. So that's why we're so dependent and have such a unique number system. What could be coming next?
As we expand upon what our math is capable of, we would need to adjust our number system, maybe even have a new number system to meet our mathematical needs.
Which we can already see the computer, big leap in math and technology, has a different system. It has binary, hexadecimal. Hexadecimal can write very large numbers compactly. Like that number in our example required 5 digits, and hexadecimal only needs 4, 3E, 3C. Binary can talk to a computer on a very natural level, and so it's easier to use a base 2 number system. And as naturally, as we see in history, we'll predict will happen, and we'll see new number systems dictated by our new needs and new types of math that will need to be done. And I believe that us, as the future generation, will be able to rise to the challenge to make those. So, thank you. It's been our talk.